Hello, this is Mrs. Polina again. This is lesson 6.05, more on confidence intervals for one proportion. Example 3. The U.S. Forest Service is considering additional restrictions on the number of vehicles allowed to enter the Yellowstone National Park. To assess public reaction, the service asks a random sample of 150 visitors if they favor the proposal. Of these, 89 say yes. Construct and interpret a 99% confidence interval for the proportion of all visitors to Yellowstone who favor the restriction. So this is very similar to the problems that we've done the other day. However, I'm going to show you some calculator tricks that you can do to lessen some of the work. So the steps are the same. The first step, step 1, is to define a parameter. And again, it's categorical data because it's either a yes or no response to the question. So it's not quantitative, it's categorical. And so we're going to define P. So put the video on hold and define P. The response would be P equals the true proportion of visitors to Yellowstone Park who would favor the proposal. So step 2 is to state and verify the conditions. And I want you to put the video on hold and verify the 3 conditions. So we have a random sample as stated. The 10% condition, it is reasonable to assume that there are more than 1,500 visitors to Yellowstone National Park. And then the large count condition, that's NP hat and NQ hat. P hat is 89 over 150, which is approximately 0.5933. You can actually use a fraction here. I just know that I'm going to want to approximate P hat when I substitute into the formula, and so that's when I did that there. You need to make a concluding statement. So I wrote, since conditions have been met, we can construct a one proportion Z interval. A main purpose of this statement is that in order to receive full credit on the AP exam, you actually have to either name the test or name the interval. And so it's really important to include it, and this is a great space to do that. We're now up to step 3, which is actually to do your calculations in your construction. And again, the general formula is the point estimate, which in this case is P hat, plus or minus the margin of error. The margin of error consists of the critical value based on the 99% confidence interval. And then the standard error, which is P hat Q hat over N. This is given to you on the reference sheet. So again, you need to have that reference sheet out at all times. So let's calculate the critical value. We're looking at the middle 99%. When you have a confidence level, it's that middle 99%. And that leaves your alpha as 1 minus 0.99 or 0.01. If I divide that in 2, I get 0.005. So in order for me to calculate that critical value, so that would be 0.005, you would do inverse norm, 0.005, 0, 1, and you get a critical value of 2.576. So our point estimate that we calculated before, 89 of 150, is 0.5933. Plus or minus the critical value, 2.576, and then we substitute in. Now, even with the calculator trick that I'm about to show you, you still need to make the substitution in. And by the way, it was 150. So you need to show the step. You need to show the parameter. You need to show the 3 conditions. You need to show the summary statement. You don't need to write the general formula, but you need to show the substitutions into the formula. Okay? You don't need to actually show the calculation of the critical value, especially something like 99, the one for 99 confidence level, because those are standard. You should draw the picture in each case. So how do I save you time? Let's go to the calculator, because this is great for crunching the numbers. So we're going to clear our screen by hitting Menu, Actions, Clear History. I like working with a clean slate. And now we're going to hit Menu, Statistics. We're still in Statistics. Option C is confidence level. And notice we have all these choices. Z interval and 1 proportion Z interval are not the same thing. In fact, we are never going to use option 1. We'll discuss that later on in the course. Again, we're dealing with a single proportion, so we're option number 5. So let's click that. So X is the number of successes. It has to be an integer. In this case, it was 89. Our sample size was 150. And make sure to change your confidence level. The default is 0.95, where you're going to do 0.99. Okay, let me try to clear that. And we hit OK. And when we do that, notice what happens. We get our proportion. We get our margin of error. So it certainly saves us some number crunching. So let me show you what you're going to do from here. Okay, so again, you have to show the substitutions. I want you to show the point estimate always. There's a method to my madness, which I'll explain at another point. You're going to list out the margin of error, which was 0.1033. And then you can right away say your lower end of the confidence limit, which was 0.490. And the upper limit is 0.6966. It may not look like it saves time, but it actually saves a lot of time with the calculations. And now we're up to the last step of Part A, where we state our conclusions. So I want you to put the video on hold and try it. So let's check out your answer. We are... Notice you're filling in 99% confident that the interval, and now you enter your interval in, from 0.490 to 0.6966 captures the true proportion of visitors to Yellowstone National Park who support the proposal. That should say who, not or. Okay, and then let's go to Part B. And we can talk about it. Based on your work in Part A, can the U.S. Forest Service conclude that more than half of the visitors in Yellowstone Park favor the proposal? So let's take a look at the confidence interval. So for Part B, I'm looking to see if the majority, that's over 50%, support the proposal. And yeah, it's true that 50% is contained in the interval, but we also have values that are less than 50%. So since there are values both above and below 50% within the interval, we do not have sufficient evidence that the majority of the visitors support the proposal. It's plausible that we have less than 50% who support it. So again, it's inconclusive, and you would have to do another study in order to determine the support.